Welcome everyone to lesson 14, linear regression. That might seem a little confusing at first, but that's going to be a new vocabulary that we're going to learn today. We're going to learn a lot of vocabulary. Now, before going on, make sure that you open desmos.com because we are going to be using that in today's lesson. So that's desmos.com and sign in with your school address. Then you're going to answer the actually one question, not two, just the one question as a little warm up. So get to it and then continue the video. So as a reminder, since we want slope-intercept form, we want y equals mx plus b. We're given a point and we're told that we're perpendicular to this. Now we are in slope-intercept form, so I can say that m equals 2/3, but because I want to be perpendicular, I need the opposite, which is negative, reciprocal 3/2. So this is the m that I'm going to use. You can go from any form. I'm going to do point slope and transform it. So y plus 7 equals negative 3/2 x minus 4. Distribute y plus 7 equals negative 3/2 x. Negative negative makes a positive, 12 over 2, so that's 6 minus 7 minus 7. Y equals negative 3/2 x minus 1. So that is our equation that goes through 4 comma negative 7 and is perpendicular to that given equation. Okay, so let's look at today's objectives. So today our objective is to understand how to use writing linear equations with statistics. So we're going to integrate some statistics today. We're going to learn about what is the line of best fit and what it means to perform linear regression. I bolded those words because those words are new vocabulary for us today. So we are going to use Desmos. We're going to use Desmos to create what's called a scatter plot. Now, before we go on, I need to define what a scatter plot is. It is a graph of all our data points. Now, we're saying to let X represent years since 1990 for this situation. And that's why I rewrote this second table showing 0, because 1990 is 0 years from 1990. Now, I am going to be splitting my screen with Desmos in one and this table in the other. So now you're going to be able to watch how we do this. Now, the first part's really easy. To make the scatter plot, I hit my parentheses, 0, comma, 122.9. Now, what I like is this lovely label here. So I'm going to label it, and I'm going to label it A. Now you're going to be able to put in the rest of your points. You just click on number 2, and you write that in. Now I'm going to zoom out for a second because we're going to, well, there's A right there. And if I highlight it, I'll be able to see it. So you're going to now input the rest of those data points, then take a screenshot that you're going to be putting into your notes that you're going to be uploading later. Now, once you plug it in, it's sometimes hard to see this because to see the points, you have to zoom out this far. So often what they do in statistics, what I'm going to show you in a moment, so this is our scatter plot. What they often do in statistics, and you're allowed to do, you are allowed to do this when dealing with statistics. is create a break in the graph. Now, notice right here, this little thing is that The idea is what they're saying is from 0 to 110, it's all in there. But there's no data there, so to make the image look better, we can sort of say, yeah, from here to there, there's just no data. And now it's clearer. So here is another scatter plot. This is A, that was B, C, D, E, F. It's the same points, but it's clearer. Now, here's what we're going to be doing. We're going to be determining the line of best fit. Now, to find the line of best fit, what that means is to write an equation that best represents the data. So let's look at some lines that we can do. Well, if I picked this point and that point, and I connected them with a line, well, I wouldn't say that's a good line because all of this data below here, it's below, it's not evenly spread out. I don't think that's a good representation. This is what we're doing. We're trying to find the line of best fit. I'm gonna pick the second point and this point. Let's see. Ooh, that gets a lot of my data. That first point right here, this point right here, we sometimes call an outlier. A point that, if there's one point that just doesn't fit the line. So this might be my line of best fit, but you can all potentially have different answers because you might pick different points. So step one is picking the 2 points you're going to use. And I'm going to use this point, and I'm going to use this point. Performing linear regression is the act of actually finding that equation. In the future, there's quadratic regression, cubic regression, exponential regression. It's the act of actually finding this line. So my ordered pair, my second ordered pair, so I'm using the ordered pair 2, 121.5, and I'm using 8, 152.5. So I'm going to pause the video here for a moment, and I want you to write an equation. Pretend the question was, write an equation in any form that goes through these 2 ordered pairs. So I'm going to pause the video and let you try. So here is my equation. Y minus 152.5 equals 31.6 all times x minus 8. Now, you could have used the other ordered pair. I don't suggest doing slope-intercept for this unless I ask you to get there. And so here is my equation. So this, if we're trying to think of terminology, this right here is what we call our line of best fit. We just found it. The actual act of doing, the act of calculating is linear regression. Okay, so here's the next thing that I want you to do. And we're going to do this together in a moment. So we are going to, before I go on, we're going to put this into Desmos. Now, this is going to be a little tricky for a second, so you need to follow carefully. I'm going to my next ordered pair. I'm just going to start typing y minus 152.5 equals 31 divided by 6, x minus 8. So look at that, passing all of our data. Pretty cool. Now, I'm going to teach you something else. We are going to restrict the domain. We are going to restrict the domain. Now, domain is our possible inputs, which in this case is our possible years. Now, for this, our years are starting at 1990, so we're not going to go backwards, which means we want our domain, our possible x values, to be greater than or equal to 0, which means 1990 and beyond. So here's how I do that. I'm going to go into my equation. I am going to use the bracket. I must use the bracket, and I'm going to type this. X is greater than or equal to 0, close bracket, and all of a sudden, look, it stops. It goes to 0 and stops. All right. Now, let's go back here. Let's go over here. So what is the purpose? Well, I'm just going to type this out because it's just the purpose of finding the line of best fit is to make future predictions based on a visible trend. We have a trend and we want to make predictions. And so we're going to do just that. So our equation that we just had, y minus 152.5 equals 31.6, all multiplied by x minus 8. Well, let's figure out the median price in 2019. Well, x is, again, years since 1990. So 2019 is 29 years. So we're going to say y minus 152.5 equals 31.6 times 29 minus 8, which is y minus 152.5 equals 31.6 times 21. This is where you can use a calculator. You should be using a calculator. I'm getting mine out right now. So I'm going to do 31.6 times 21, and I'm going to get y minus 152.5 equals a 108.5. Add this to the other side. Oh, ran out of space. And I get y equals a 261, which means the median price in 2019 was 261,000. Now, let's see how accurate we were. It was actually 310,000, which means it's pretty off. So these lines of best fit, they're not a guarantee. They're a prediction. So now you're going to have one practice problem. Now these practice problems take a while. I've broken it down to walk you through it. So the following practice problem, you will upload this to Google Classroom. I give you the years from 94 to 2004 and the consumption in billions. So this is 113 billion gallons of gas were consumed that year in the US. Make sure you follow the instructions carefully and upload your final answer.